This our guys, I need y'all to stop talking. We're back to it. It reconnected. It's working now. Okay, so so far we've revealed real numbers that can just be, that's anything that you've dealt with number wise. Okay, y'all have not learned imaginary numbers yet. So yeah, I know. But fractions, decimals, whole, positive, negative, those are all real. Okay, sum is an answer when you add. Perfect squares we've talked about. Those are numbers you can take the square root of and get an integer. I really hope you know odd numbers. Divisible just means it can be evenly divided. Okay, so for example, 100 is divisible by 4 because you get 25 and not a decimal. So if you can divide by a number and you get an integer, not a decimal, then that number is divisible by whatever you divided by. Okay, that's what divisible means. I don't remember, but possibly yes. Okay, and product is the answer to multiplication problems. So when you multiply, you get a product. Okay, now here's getting into some more of our geometric terms. Okay, so remember complement. Okay, complementary meant they add to 90. Supplementary meant they add to 180. So the complement to something means that it adds to 90 with whatever it's the complement to. Okay, same thing. Supplement means that it's going to add to 180. Complement and supplement. Okay, again, I really hope you know what even numbers are. Those are all divisible by 2. So count by 2s. If it's divisible by 2, it's an even number. Okay. Adjacent, that's another geometry term. Okay. Oh, okay. Sorry, every time I move that box, the screen moves. I have to move the screen. So adjacent just means next to. They are sharing a side. Yes.
There's one on the paper that's not on the screen. Conjecture.
Oh, let me put it in. Thank you.
Thank you.
It's after even?
Yes, ma'am.
All right, conjectures on there. I left conjecture off. Sorry. Okay, so a conjecture we talked about on Friday when we talked about inductive reasoning. We said it's a concluding statement reached using inductive reasoning. Okay, the conclusion that you draw when you use inductive reasoning, which remember inductive reasoning used like patterns, examples that you, okay, that's drawing conclusions based on those things. That's inductive reasoning, and the conclusion is called a conjecture. Okay. All right, back to adjacent. Adjacent angles are angles that are next to each other. They share a side. Okay. The side of one angle is also the side of another. They're neighbors. They are next to each other. Adjacent means next to. All right. Coplanar. We said in unit 1, coplanar means it's on the same plane. This says points on the same plane, but it can be lines, segments, rays. It can just on the same plane is what that means. I'm actually going to take points out. It just means on the same plane. Okay. Most often we may refer to points, but you could say this line and this point, or this line and this segment, or this ray and this line. They are coplanar. Okay, so figures that are on the same plane. Okay, a common vertex, okay, just means that two angles with the same vertex. Okay, it's a shared vertex. Okay, the angles have that in common. And collinear follows the same as coplanar. It just means on the same, but it's on the same line for collinear. Okay, so it could be points on this. That one actually is points on the same line. That one is point because you're not going to have anything else on a line. Okay, so points on the same line are collinear. All right, linear pair we talked about in unit 1. Okay, a linear pair is a pair of angles that are adjacent, meaning they share a side. Okay, they're touching. Okay, and they add to 180, so they're supplementary. So supplementary and adjacent, they form a line together. Okay, if you want to add that, okay, they form a line together. Okay, and we know a line is a straight angle is 180 degrees. Okay, now not all supplementary angles are linear pairs because supplementary angles just mean add to 180. They don't have to be touching. To be a linear pair, they have to be supplementary and adjacent. They have to be touching. They form a line together. That one's not on y'all? Okay, so y'all add that one at the bottom. Okay, so an integer is a whole number, positives or negatives. So whole numbers are technically just positives. So it's whole numbers and their opposites. So positives and negatives. So it's like you're counting numbers. Okay, 0, 1, 2, 3, 4, 5, but also -1, -2, -3, -4, -5. Okay, so no no decimal. Okay, and then consecutive, if consecutive's not on yours, add it at the bottom. Okay, consecutive just means one right after the other. Okay, so you could have in sports, you could have consecutive wins. It means back to back, right? In a row. Okay, so consecutive numbers are numbers that are next to each other. So if we're talking about integers, 1 and 2 are consecutive integers. 2 and 3 are consecutive integers. All right, do we feel okay about these definitions? Yes? Okay. So let me pull up here. I'll pass it out, but I also want to show you on the screen to show you what you're going to be doing.
So it's consecutive kind of like an integer?
Say again?
Is consecutive kind of like an integer, just not
Well, consecutive is just the adjective. This example is integer.
Oh, okay, got it.
But consecutive just means like in a row, one right after the other. Okay. All right. So what we're going to do here, you are going to get this. Make sure this is the right one for today. Yes. Okay, so you're going to want to probably have out last week's notes, okay, and then today's vocab that we added to it on counterexamples. So you're going to get this paper. This is, again, another paper practice. So you can have out Friday's notes on inductive reasoning and counterexamples, and then that vocabulary that we just refreshed on, okay, and you're going to use both of those to answer these questions. Okay, a lot of you are going to finish this in class. If you don't finish in class, finish in Cat Tracks or at home.
Okay.